Hi, and welcome to the next installment of Finding the Missing Angle. We have two more installments, this one and one more, and then we'll bring up a new topic. The first one I want to do here, I'm going to give two examples. The first is going to be involving what we remember about parallel lines. Now we indicate parallel lines with these little extra arrows inside on the lines themselves. And the direction is irrelevant. It just tells you that the two lines are parallel. No matter how badly I draw them, those lines are parallel. Well, if we cut that line with a third line, which we call this a transversal. Just trans means to cross, so kind of makes sense. We're transversing these two lines. It creates a whole series of angles. Okay? In fact, we get 1, 2, 3, 4, 5, 6, 7, 8 angles. And the angles all have something to do with each other. All the small angles, here, 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 and here, those are all going to be the same. Okay? We have a term, these are called alternate interior angles, and these are called alternate exterior angles. But the truth of the matter is they're all the same. They all have the exact same measurement. And then all the large angles, here, 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 and here, are also all the same for the same reasons. They are either alternate exterior or alternate interior angles. The other part of it is that every small and every large angle, when combined, are going to equal 180, because we've taken a straight line, which we know is 180 degrees, and we've cut it into two pieces. So every small angle is the same, every large angle is the same, and every small plus a large is always going to be 180 degrees. So let's throw that up there. Small plus large, 180 degrees. And it doesn't matter which one. So I can grab this one and that one, this large and this small, and it's going to be 180. Well, if I give this one a measurement of 125 degrees, and I give this a measurement of 3x plus, let's make it minus 1. Then I now have two angles that, as I stated, have to be equal to one another because they're both large. So as soon as I look at this and I'm asked to solve for x, which I'll say that, let's say solve for x, I now know, hey, this is a large and that's a large. That means they're equal. Well, if they're equal, we can put an equal sign between them. Now, if one was a large and one was a small, then I would do this. I would add them together to make them equal to 180. Either way, I've got a perfect equation that I can solve. And this is a nice little two-step equation we have here. And we get x is 42. Now, that's not the degrees. We always want to remember that doesn't mean this is suddenly a 42-degree angle. In fact, we know it's 125 degrees because it matches this one. It's the value that x needs to be to make that happen. So that is the value that will make the angle have the right value. And that's what we were looking for. So again, all the smalls are the same, all the larges are the same, and a small plus a large is always going to be 180 degrees. So now I got one more example. And this is a thinking outside the box kind of which is sort of meant to be a joke here. Because here we have ourselves a box. In other words, a rectangle, maybe a square, not sure. Don't know if those sides are equal. But I've extended it out here because now I have two angles here. I have an angle here, which I'm going to split. Now I've created two angles. So I have two angles that are outside of the box. However, I know this is a straight line, so I know this is 180 degrees. I know the box is a 90-degree angle, which means I know these two angles together have to add up to the remaining 90 degrees, which means they are complementary. Now I could add all three, make it supplementary, adding the 90. Let's do that, and then I'll subtract out the 90. So going to give this one a 3x plus 4. Going to give this one a 4x plus 2. Now this is going to be a perfect example of don't trust Mr. Mac's drawing skills, okay? Because I can already tell that this is going to be this is going to prove to be a larger angle numerically, but I obviously didn't draw it that way. And I would say in general, don't trust your math teacher's drawing skills. Don't look at an angle and say, well, that angle looks this size. Okay, that's the beauty of math. Figure it out. We're going to figure exactly how much that angle is. So we have angle 4x plus 2. We have angle 3x plus 4. And we have this 90-degree angle right here. And all together, that has to equal 180 degrees. Because this is a line. Lines are 180, 90 plus this plus this. So let's subtract out the 90 for a moment. Now obviously that's going to get me 4x plus 2 plus 3x plus 4 equaling 90. So now what we really are saying is these two angles are complementary. The three angles together are supplementary, the two angles are complementary. Now we're going to combine our like terms and solve our equation. Subtract 6 and we've got our value of x. Now, that's pretty much all I asked for. In fact, let me just throw that, find x. But if I were really wanting to be sure, and I want to know I did this right before I turn it in, before I present it to somebody, I would want to double check, because I know these two have to add up to 90. So let's make sure that 12 makes that happen. So 3 times 12 plus 4. 3 times 12 is 36, plus 4 is 40. 4 times 12 is 48, plus 2 is 50. 40 plus 50 sure does equal 90. I'm fairly confident we have the right values there. And you can do this too. You can always check your solutions. If you have questions, you can always email me. You can always rewind, watch this one. Go back and watch one of the earlier videos. Watch the first one if you're still missing on some of the vocabulary. Go back, take a quick look, and then this should make the homework that you're asked to do a little bit easier. Thanks.